Free response problem 2. Let's get the horizontal range of the projectile. So again, we're going to launch it at a speed v0 and an angle theta, and it flies through the air and it lands. So let's be clear. Let's begin with the hang time. So I know to get the hang time, we will in fact do the following. I launch at v0 at an angle theta, and let's remember that v0 y is going to be v0 sine theta, and the horizontal component of the initial speed, v0 x, is going to be v0 cosine theta. This never changes because there's no acceleration in the x direction, but this does because we actually have gravity accelerating us. So let's go ahead and get the hang time, and to do that, let's remember that the time up equals the time down. So let's get the time up, and we'll double it. So to that end, we have Vy equals, now this is what we're given, Vx equals V0 x plus at. Now let's make that work for projectile motion. So I have Vy equals V0 y minus gt. The idea here is that we're defining up as forwards or positive. Now V0 y is going to be V0 times the sine of theta. That's our launching speed minus gt. And then our speed at the top, we have that instantaneous velocity of 0. And so when we isolate the time, this is half of the time, just the time to get up there, we're going to end up getting V0 sine theta divided by g. So the total hang time is going to be 2 V0 sine theta divided by g. Now, once we've got the hang time, we can go ahead and get the range, and I'll do that here. So the idea here is in the x direction, we have x is 1/2. I'm going to actually write out the full equation and just kind of show you something. Here's the thing. Since we have no acceleration, we're just given the buggy lab, or the equation that we came up with when we did the buggy lab. So x is v0 xt plus x0. So x equals, here v0 x is going to be v0 cosine theta, and the total time that we travel for is the hang time. This time in the air going up and down is the same time we spend going horizontally. How could it not be? Times 2 v0 sine theta divided by g. And so when we simplify this, x is going to be v0 squared 2 sine theta cosine theta divided by g. Okay? And I wanted to say show that the complementary angles give identical ranges. So check this out. The range formula, I'm not going to write it using the double angle formula. I'm going to write v0 squared, 2 v0 squared, sine theta, cosine theta divided by g is the range. Now check this out. For the complementary angle, we go from theta and we plug in 90 minus theta for the complement. Well, look what happens for the complement range. We put in 2 v0 squared. What was theta before is now 90 minus theta. And cosine is also 90 minus theta divided by g. And check this out. The sine of 90 minus theta is the same as cosine theta. Cosine of 90 minus theta is the same as sine of theta. So we actually end up getting identical ranges. Okay? Now, for the difference in height, let's actually figure this out. So let's get the height formula now. To get the height, I'm going to use the formula v squared equals v0 squared plus 2a x minus x0 from the AP. Not helpful. We need the y formula. So I know at the very top the speed is 0. My launching speed in the y direction is v0 squared sine squared theta minus 2 times g times h, the height I get to, minus my starting position of 0. When I isolate height, I'm going to get h equals v0 squared sine squared theta all over 2g. And then the height for the complement is going to be v naught squared sine squared of 90 minus theta all over 2g. So if I wanted, since this is 90 minus theta, sine of 90 minus theta is cosine of theta, h is going to be v naught squared sine squared theta minus cosine squared theta all over 2g. There are some double angle formulas I suppose we could use here if we wanted to. I'm just, I leave it like this, but if I were feeling fancy, I'd try to find the double angle. Like, I think it's like cosine of 2 theta or something like that. Is it? We can check that. Is this cosine of 2 theta? I don't remember, but we can definitely check it out later. So that's the difference in height between the two of them. All right. You notice how much trig you have to remember for that? Isn't that mean? What a meanie. All right. So that's the second free response question.